Good morning, everyone. Now let's talk about cross-organizational secure data exchange with access control using blockchain. My name is Qiong Zhang, and I'm from Fujitsu Labs America. This project is majorly done by my colleagues from Fujitsu Labs Limited in Japan. Various data are generated by IoT systems, sensors, monitors, and IT systems. Proper usage of massive data is the key for digital transformation. And data can be transformed to intelligence by AI or machine learning algorithms in many areas, such as predictive maintenance, anomaly detection, operator support, and clinical judgment support, and etc. Data is the oil of 21st century. It is expected that in the year of 2025, the amount of data generated will reach 175 zettabytes. The current data flow in real and the cyber world is that many companies are independently collecting and utilizing data. A new data flow in the near future is to have secure and appropriate data exchange among companies and organizations. However, there are concerns on how to use data and data exchange. Fujitsu Global Digital Transformation Survey is carried out in February 2019, and we asked 900 business leaders in 9 countries. Among them, 72% concerned that organizations exploit personal data without permission. And 59% of them concerned that data they use may have been falsified. And 70% of them found it difficult to judge if online information is correct and trustworthy. In the meantime, there are challenges on data exchange. First, in data utilization, there are diversity of data formats and models. It is challenging to convert different data models and the data models for different data users. Second, in data discovery phase, it is challenging to find the desired data because there is no information about the data and the location of the data can be unknown. In the data providing phase, there is a resistance for data sharing and data providing due to the security and the privacy concerns and unclear cost effectiveness. In this presentation, we'll focus on these 2 challenges. Most current data exchange systems are centralized. Data from different sources are transferred to a centralized cloud, and then the management and the security of data depend on cloud vendors. And there is a more trustworthy data exchange, which is decentralized data exchange. In such decentralized data exchange system, each and every owner manages his own data and can set the data access control policies for his own data. And the data owners and data users are connected with each other. There are requirements for such decentralized data exchange system. In data discovery, we need to find out what are the available data and where they are. So a metadata directory is a must. Metadata directory basically is a distributed collection of metadata. And metadata is the description of data set, and it can include the data ID of the data, the attributes of the data, and the access policies of this data. After data was found from the metadata directory, in the data providing phase, we need to have data access control for the data provider, and we also need to have a secure peer-to-peer data transfer to transfer the data from the data provider to the data user. For better satisfy these requirements, we can take advantage of the functions available in blockchain. For example, the data access control can be more secure by using smart contract because smart contract is executed at more than one node, verifying the data access control policies. And the peer-to-peer data transfer control can also use smart contract to act as a network controller to forward the data transfer requests. And then data trace management basically is to track the data exchange transactions. And the metadata directory, again, is a decentralized collection of metadata. And these two requirements can take advantage of the distributed ledger to have decentralized management. Fujitsu has developed a decentralized data exchange system, VPX. VPX stands for Virtual Private Digital Exchange System. Now let's talk about more detail about it. VPX technology is a peer-to-peer communication technology. It has 4 major functions, as we described previously. One is data access control, one is metadata directory, and one is peer-to-peer data transfer control, and then data trace management. And VPX technology is also a blockchain technology. There are different types of blockchains. We can have public type, consortium type, and private type. Here, VPX focuses on data exchange among several companies. So we chose to have consortium type of blockchain, where there are multiple administrators, and we use permissioned blockchain with cross-validation for consensus algorithm. And we chose to develop a VPX based on Hyperledger Fabric. Here, we show the VPX architecture. We have data provider and data user. Data provider and the users can join the consortium by locally installing VPX gateways. Data provider can publish and share metadata with data access control policies on the Hyperledger Fabric. And data stay locally and can be found based on the data ID by the reverse proxy. And then data are transferred from provider to user through VPX gateways and not through the Hyperledger Fabric. Now let's discuss some major APIs for VPX users. First, data provider can set access policies for his own data, as well as the metadata of his data, and those access policies can be stored in the metadata. There is a metadata publish API for data providers to publish metadata on the distributed ledger. And there is a metadata get API for data users to retrieve a list of accessible metadata from the distributed ledger. And then the data user can discover what are the available data and find the desired data. After that, there is a data get API to transfer the data from data provider to the data user securely. And there is a trails get API to retrieve the trace information of data exchange transactions. From the trace, we can know that how many data exchanges occurred, and the details of data exchange, such as who is the data provider, who is the data user, what is the metadata, those details must follow the set and the configured access policy. We can see that those APIs are very easy to use for VPX users. It hides the complexity of the underlying procedures using smart contract. Now let's look at those complicated VPX procedures using smart contract. Step 1 is for data provider to publish metadata. Here, data provider is on the left side, and data user is on the right side. It corresponds to the metadata publish API. For this step, first, data provider registers metadata to its VPX gateway, locally installed. And here is how a metadata looks like. It has data ID, can be hash number of certain values. It has attributes of the data, and it has destination address, which is the address of the VPX gateway. It is encrypted. And it has access policy. So here is accessible to user X. After receiving this metadata registration, the VPX gateway verifies the data provider and then distribute this metadata onto the distributed ledger. And then, once each VPI gateway receives this metadata, it will create a forwarding table and address translation table. This table will be used in the data transfer step later for route data transfer requests. The second step is for the data user to retrieve the set of metadata and find the desired data. And it corresponds to the metadata get API. So in this step, the data user sends a request for metadata to its VPX gateway. And then the VPX gateway verifies data user and its access right of the metadata on the ledger, and then return the list of metadata that user X can access. And then the third step is transfer of the actual data. It corresponds to the data get API. So here, the data user sends a request to the desired data to its own VPX gateway. And then the VPX gateway verifies the data user and its access right of the data. And then it acts as a reverse proxy. And here, basically, the VPX gateway checks this forwarding and address translation table and find out that the address for the data transfer request to send it to next. So here, in this case, address C is the address to send the data transfer request to. So it's sent to the address C here, basically is the address of the VPX gateway at the data provider site. And similarly, in this VPX gateway, it will verify the data user and its access right of the data. And then again, it also acts as reverse proxy. It checks this table and find out the next address to forward the data transfer request to, which is address A, which is the real data provider. And then once the request reaches the real data provider, the data provider starts to sending data to the data user through the VPX gateway. During that, these VPX gateways will check the hash number of the getting data to make sure the integrity of the data and make sure that it is not falsified. We can see that all requests and data go through VPX gateways, thus hiding the location of the actual data from VPX participants for better security. Here we show the VPX traces on the ledger. The log of each VPX API call is stored on the ledger. Participants can trace the data exchange transactions. Here is the trace information via trails get API. And at the block number 20, this is the log of data get API. And at the block 6, this is the log of metadata publish API. Now we show a demo for VPX network. Here is the overall VPX network view. This is the trace information. And we have a data provider, which is the department store, and the data user A and data user B. First, the data provider set the data access policy accessible to both user A and user B. And this metadata is published. and it is shown at user A and user B. And next, the data provider would like to change data access policy to be accessible to only user A. So it also published this metadata, and we can see that the metadata on user B disappeared. And the user A can still access the metadata. And then user A starts to purchase the data. First, it will get the API documents of the data about how to use the data. And then user A gets the data. And all those transactions on data exchange is recorded on the blockchain. And we can see that using this decentralized data exchange system, data provider is very easy to change the access policy for his own data so that it makes them more confident and more willing to share data. And Fujitsu Intelligent Data Service, called Virtuora DX, was commercially launched in Japan on May 14, 2018. And this Virtuora DX commercialized service adopted the VPX technology. And we also had a data exchange trial using Virtuora DX and VPX for urban designing. The purpose of this trial is to make central Tokyo an attractive place. The participating companies include a real estate company and a mobile company. Participating companies provide and exchange data related to central Tokyo via VPX and analyze the data collected by VPX. Because this is a new service and people are very interested and curious about it, so they're willing to try it in different ways. So we have seen that more data were exchanged among participating companies, and the cross-analysis were conducted using a variety of data. Now here we have a little summary. And VPX has several benefits. It has easy-to-use APIs. It hides the complexity for developing secure and distributed platforms. It provides data exchange flexibility in terms of data sizes. For massive data, we can directly transfer from the data provider to the data user. And for small data, we can publish it on the distributed ledger through metadata. And we also had several VPX extensions. One is multi-class VPX for improved scalability. One is chain data lineage for better trust. One is federated learning on VPX for better data privacy. Now we will talk about each of them in high level. To improve the scalability, multi-class VPX divides a larger VPX network into multiple clusters. Within a cluster, it is the same as a regular VPX network. We can publish metadata, we can get metadata among VPX gateways. But between clusters, metadata and the data are exchanged via representative nodes. Chain data lineage. This technology is to integrate data processing history and data exchange history to provide end-to-end data traceability for a new level of trust. So here, data processing history is at each individual company. Usually it's in their data lineage system. It shows how data are converted and processed. And the data exchange history is recorded on blockchain VPX. Then we integrated both using hash values and form a chain, which is called chain data lineage. By doing that, the data origin can be traceable and can be more trustworthy. And we recently produced a video on chain data lineage. At the end of the presentation, I would like to show you the recent video. Federated learning on VPX is our third extension on VPX. Our experiments have shown that VPX can seamlessly provide a secure, distributed platform for federated learning tasks. Do you know about federated learning? Raise your hand if you know. Great. So federated learning is a distributed AI and machine learning approach. It trains AI and machine learning models locally at the client or on-premise where local data are stored. Federated learning usually involves a group of federated learning clients. They usually store local data and a federated learning server. During federated learning process, AI and machine models are exchanged between clients and the server. Not the real or actual data are exchanged here. Basically, the local data remain local. So it has better data privacy. Federated learning may have hundreds or thousands of training rounds in order to achieve, in order to converge to certain accuracy of the training model. So here we show 3 basic steps in a single training round in federated learning. The first step, a federated learning server provides a global AI and machine learning model to a group of clients. So here we have 2. For doing that, we can use metadata publish API to publish the global model metadata onto the distributed ledger. And the second step, clients get the global model and train it locally with the local data, and then provide the new local model back to the server. For doing this step, we can call, each client can call metadata get API to get the global model metadata, and call the data get to get the global model. And then it trained the local model, and then it can call metadata publish API to publish the local model metadata onto the distributed ledger. Then on the third step, the server gets the local model and aggregates them to a new global model. And for doing that, again, we can call metadata get API and data get API to get the local model at the federated learning server. So once the new global model is obtained, the federated learning server can further use it to proceed the next training round and repeating step 1, 2, 3. We can take advantage of the consensus made on the ledger to synchronize the global model updates among these federated learning clients. So here we can see that the AI and machine learning models is actually the VPX data to exchange in the system. And the AI and machine learning model metadata actually is a VPX metadata. So there is no real data exchange here. And then the federated learning server and the federated learning clients, they are both data providers and data users. And we can see that with this basic VPX APIs, we are able to perform federated learning tasks in a very stable manner and in distributed settings. Okay, now I would like to show you the video of chain data lineage, as I promised.
Our world is more connected and more globally integrated than ever before. Massive quantities of data are being mined and shared to create new values and services. This leaves us with unanswered questions. What is the source of the data? Do we have permission to use it? Who will use our data and how? We don't know. Fujitsu knows that creating, trading, and using data means it must be trustworthy. This is why we created a new blockchain data history management technology, Chain Data Lineage. Chain Data Lineage lets organizations exchange data that is securely verified. Let's see how this works. Data is collected and processed. The data is shared among other organizations that process and use it. The data has a data exchange history that is shared. The data processing history is managed by each company and can also be shared when needed. If we look at a single item of data, all related history is picked up and can be viewed in graphical form. The history includes data exchange history, data processing history, the original form of the data, and other information. Chain Data Lineage is a blockchain data history management technology. It unifies data processing history and data exchange history that until now was scattered and distributed. It does this by using hash values of these histories, which are linked together and managed and shared on blockchain. Chain Data Lineage manages the hash values of the exchange history and processing history by blockchain, which avoids falsification and fabrication. Chain Data Lineage goes further by adding consent to use information to the data exchange history for supporting personal data exchange. Data users can check that they can use the data safely by verifying its source and history. Data providers can also verify who is using the data they provide and how. Many organizations and industries can benefit from this technology. It has a wide range of applications, such as automobile insurance, new drug development, and logistics. The secret of trustworthiness is verification. With Chain Data Lineage, the power of blockchain takes trust to a new level with a verified history of critical data commodities.
Fujitsu, shaping tomorrow with you.
Thank you. Now we have time for questions. Sure. Yes. That's a very good question. And we did not use that feature. And our metadata actually is majorly for access control for the larger data stored locally. So yeah, we did not use that feature. We may be considering in the future. Yeah. For the metadata, we have also access control policies. Not only the data have access control policy, the metadata also have access control policies. So it's only exposed to the one who has the access right. It is actually on smart contract, because when we publish the metadata and the access policy on the metadata, whenever people retrieve the metadata, will be checked and it will be verified among multiple nodes. Mm-hmm. It's not a blockchain format because it's a massive data. It's hard to put on the blockchain. So we, the control of the transfer, basically looking for the route the data transfer request is done by smart contract on the blockchain. But when we transfer the large data, it's out of the blockchain, and it's using HTTPS, the overlay network.